All right, part two. By the way, great class today. Thought the energy was outstanding. So, all right, so we're gonna have to do these tougher ones here together on the video, but hopefully you're gonna be able to get these. And again, you can see like here we talked about the idea of taking the square root of, right? And so we worked our way backwards down this list to kind of get some easy anchor points for us to draw our graph, and we figured out that this particular type of function, right, cannot have any negative domain numbers because we can't put a negative inside of here. And so we can't have any negative domain numbers. And there's never a way that we're going to be able to produce a negative output. So really we can't have any negative y values. And so that's how we end up here, right? But now keep in mind, when we change things up and we put some math around this particular square root thing, that does kind of change things just a little bit, right? Like take, for example, if we take a -5 and we drop it in here into the input, we've got to do this math first, right? So -5 plus 3 is going to leave us with a -2 inside of here. Okay, well, we know that that's not possible, right? We can't have a negative inside of our square root sign. That's not something we can do. So in this case, we know that -5 is not a valid input because it leaves us with a negative inside of our radical. So just like we couldn't have a 0 in the denominator, we know we can't have a negative inside here. So this is going to be an NA for us right here. But if we take a -3 and we drop it in here, well, -3 minus 3 is 0. And we could take the square root of 0, right? Because what times itself gives us 0? 0 does. So the square root of 0 is 0. And then we add 2. And so dropping a -3 in there is going to get us +2. All right. So why don't you do these three right here and then put the points on the graph where you think they go. Go ahead, give that a try. All right, so here's the values you should have come up with for this one. And then you can see I put my points on my graph here. Now, if we're following the same pattern as we saw over here with these square root graphs, right, these square root functions, then this should probably go something like a curve going like this, right, and kind of heading off that way. So now the thing is we said, well, hang on a second, we couldn't have any negative x values, right, because you can't have a negative in the square root. But now because there's some math in there, it's kind of changed things. In fact, -3 really still works for us, but -4 doesn't, because that would produce a -1, and -5, and -6, and -7, and so on and so forth. So you can see, like the other ones, once we start plugging in some math here, it's almost like the graph sort of starts to move around a little bit, right? But of course, our no-go zone, right, if I'm going to go over here and get my little highlighter tool, our no-go zone for our x values now is anything less than -3, right? So this is all, well, yeah, there we go. I had a little all no-go there, right? And also, right, when we start looking at the values here, as far as this goes, -3, right, we can't go any lower than that, because if we went any lower than that, then we're going to start to get negative values out here on the outside. And so our no-go zone here is going to look like this, right? And so we're going to be talking about this area down here. So that should give you an idea of how to write your limitations for your domain and range. So why don't you go ahead and write those, and let's see how you do. All right, how'd you do? Here's your domain and your range. Again, domain, right, has to remain greater than -3. So we have to stay to the right of this -3 line here, right? And of course, if we put a -3 in there, we're going to get a +2. That's the lowest our graph's going to go, because every time we move over another domain number, right, if we go -3, we go -2, we're going to get +1 under here. Square root of 1 is 1. 1 plus 2 is 3. And so it's going to continue to go up. So as we can't move to the left, and as we move to the right, the graph continues to go up. So that makes this line right here, this +2 line, the absolute lowest our graph will ever go. And so that's why our range has to be greater than or equal to +2. So again, you can see how doing the math to the input affects the look of the output. Now, let's talk about these two down here, right? So these two you have over here. This is where you're going to be checking your work, for example, 15 and 16, right? And typing in your domain and range over here. And so again, keep in mind where these negatives and things are positioned, right? Like for number 15, it's drop an input, subtract 2, then take the square root, then multiply by -1, and lastly add 4. Okay, say that one more time. Drop the input in, subtract -2, or add -2, then take the square root, then multiply by -1, then add 4. See what I did there? Okay, if you need to replay that, replay that. Now, the input in this one over here is drop the input in, multiply by -1, then take the square root, and then after you have that value, subtract 4. So that's what you're doing with these inputs, and then it'll be interesting if you can figure out, how do these look, and if you want to continue to do that little no-go zone there, you can do that as well. But I'll let you check those in terms of the answers that you type in, and you should be able to clear your answers on formative. Then you'll know at least if you have the right inputs and outputs, okay? All right, so then with that said, I'm going to move on to the next function that we're going to be looking at, which is function number 5. Here we go. Now, with all of these last two that we're going to do, all the questions are going to be available for you, but let's just try to stay focused on what we're working on so that you don't miss some important things here, okay? So try to focus your attention on these. So these are what we call exponential functions, all right? And exponential functions, we're going to make a little note right here, is where the input is the exponent. The input is the exponent. And so you can see in the parent function right here, we have this f of x is equal to 2 to the x power, right? So now the input is the exponent. Like before we saw input raised to a power, now we've got a number raised to the input. That's the difference here, right? So again, another different kind of Mustang here, right? And our inputs now are going to go in as the exponent, and then we're going to process them. Now, it is kind of important just to mention on a bit of a side note, and we're going to talk about this more a little bit later, but if you want to highlight this 2 right there, that value, which we would call the base of an exponential expression, right? So in an exponential expression, there's the base and then the exponent, right? The base is the thing being multiplied a repeated number of times. The exponent is how many times are we multiplying it by itself, right? So the base right here, this can and will change. And when that does change, it's going to affect the way that the exponential function looks. Okay, so for example, we have the parent function here, f of x is equal to the x. Well, actually, we could change this word example here to parent function as well. I'm just going to abbreviate that because this is the parent function for base 4. And when I say parent function, what I mean is we're not doing any other math to the input. The base is different. You can see here, it's 4 to the input. This is 2 to the input. And so when those bases change, that's going to obviously have an impact on the output. And so we'll talk more about that because we're going to look at these in detail as well. Okay, but for now, let's just take some of these and kind of hammer them out just a little bit. Now, how you do these just kind of depends on, what kind of a calculator you have and how you can figure them out. But let's just talk about something for a second. Let's take this first one. I'm going to swoop a little arrow over here so we can do this one. All right, so what this one is 2 to the -4th power. 2 to the -4th power. Okay, we're dropping the -4 in for the input. Now, to do negative exponents, all right, we're going to take this and we're going to write it over 1, and then we're going to do this little trick where we flip-a-rooski the numerator and the denominator, and so we're going to write this 1 over 2 to the +4th. So we do this little flip-a-rooski deal here, and I can explain to you why we do that more. This is just sort of a shortcut, but we're going to take that numerator and flip it down here to the bottom, and that's going to change our exponent to a positive. We'll talk more about this later on, like the specifics of why that works the way that it does, but then from there, we can simplify that out. And 2 to the 4th power is just 2 times 2 times 2 times 2, right? So 2 times 2 times 2 times 2. So we got 4 times 2 is 8 times 2 is 16 on the bottom, and so we have 1/16 over here. All right, how are we going to graph that? Well, let's not worry about that too much right at just this second. But again, let's talk about this one right here. So, okay, if we took this one, this is going to be, let's swoop a little arrow over here. This is going to be 2 to the -2nd power. Well, let's put that over 1. And then we'll do our little switcherooski, and that's going to be 1 over 2 to the positive second power, or 1/4. Getting closer to graphing that one. Let's talk about this one here. This is going to be 2 to the 0th power. What is anything to the 0th power? Well, that's always 1, right? Any value to the 0th power is 1. Okay, so that's how we deal with the negatives when we're plugging them in for our exponential functions. And then, of course, we have 2 to the first power. Well, that's just 2. And then 2 to the second power. Well, that's 4. And then 2 to the third power. Well, that's 2 times 2 times 2. So that's 2 to the 8th, or 2 to the third power is 8. And so these are our outputs for our function. Now, when we're graphing this, let's just, again, graph this kind of backwards just to see how this works. So let's go with 3, 8. All right, so I'm going to kind of zoom in over here like this. We're going to go 1, 2, 3, x input, and then all the way up to the top here, 8. And then let's go 2, 4. So 1, 2, and then up 1, 2, 3, 4, like that. So 2, 4. All right, and then let's go 1, 2. So 1 and then up 2 like that. And then, of course, we have 0, 1. That's an easy one right there, right? Now, you can see, just based on those right there, that you're starting to kind of get this kind of curvy sort of thing going on like we saw earlier with our quadratics, right? Because it's not a constant rate of change, right? It's not like up and over and up the same amount, right? This is over 1 and up 2. This is over 2 and up 1, 2, 3, 4, like that. And so we've got that sort of same curvy kind of thing going on here. But then it doesn't flip and go the other direction, because then you can see our outputs start to go negative, right? So like -2 is got an output of 1/4. Now, if we were to ballpark this, right, let's just go -1, 2, and 1/4. So that's going to be a fourth here. So like, I'm going to zoom in even further. So -1, 2, and then a fourth. Well, this is a half right here, right? So maybe half of a half. So like there-ish, something like that, right? And then at -4, we're at 1/16. Wow. All right, -4, we're at 1. Well, I don't know what we're going to be able to do with the graph with that, but it's going to be pretty far down. It's here -2, -3, -4. So it's going to be pretty down here like this, right? All right, now I want you to think about something for a second, right? As this number gets smaller, -4, -6, -8, -12, like that, right? All that's going to do is increase this value down here in our fraction. So, right, if we go, -6 here, then it's going to be 1 over 2 to the positive 6th, right? And that's going to be an even smaller fraction, and an even smaller fraction, and an even smaller fraction, and an even smaller fraction. And it's going to keep smaller and smaller and smaller, right? But I want you to think about it. As we continue to go negative here, will we ever produce an output of 0? And the answer is no. We will never produce an output of 0. In fact, with this particular graph, what's going to happen is it's going to come along here, and it's going to hit that point, and it's going to hit that point, and then it's just going to continue to go ever closer to that line fractionally, and getting smaller and 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 smaller, all the way down. But it's never ever going to turn into a 0, because this is never going to go away. It's just going to keep making a smaller and smaller and smaller and smaller and smaller fraction. So it's never going to cross a 0. Now, I want you to think about something. This is continuing to go up and to the right, and this is continuing to go to the left here, right? So then how would you document your domain and your range for this one? Why don't you give it a try? Let's see how you do. Go ahead. Try your domain and your range. All right. Take a look and see how you did. Of course, your domain is your set of all real numbers, right? I just said that. It's going to continue to go to the left. It's going to continue to go up and to the right. That means that there are no limitations placed on which x values you can plug into this function. However, there are limitations on the outputs that you can get. As we can see over here, if we go positive numbers, our outputs get bigger and bigger and bigger. And if we go negative numbers, our outputs get smaller and smaller and smaller, but they never produce a 0. So in this case, we cannot have a 0 value. Now, not only does it have to stay above 0, it cannot be equal to 0 because it's never going to produce a 0. And so in that case, it's super important that you recognize that this is not and or equal to. We've been using or equal tos in some of our other range limitations, but this one, it cannot be equal to 0. Everything above 0 is perfectly fine. 0.00000000000000175 works because that's greater than 0, but 0 itself does not work. And so that's why it cannot be an or equal to. Okay? All right, so let's see what happens over here. Now, utilize what we talked about how to do your little fraction flippity-do thing, all right? And then see if you can come up with some points and a graph and a domain and a range for this one, and then we'll talk it through in just a minute. All right, go ahead and work on this one, and then we'll go over it together. All right, let's take a look. So I put some of the math over here for the negative exponents, right? Again, just doing my little flippity-do trick over here. And then again, anything to the 0th power is 1. Now you'll notice something different between these two graphs. As the base number got bigger, those numbers that were positive numbers that were increasing larger and larger got bigger much faster, right? This one goes 1, 2, 4, 8. This one goes 1, 4, 16, 64. This larger number, because we're doing that repeated multiplication with a bigger number, is going to force that graph to shoot up a lot faster and a lot quicker. So this one is spread out a little bit more, while this one jacks straight up real quick like. But in either case, those fractions are still getting smaller and smaller and smaller this way. And so as they go down this way, we never get to that 0 mark, but we continue to get smaller and smaller. We just get smaller and smaller, faster and faster because of the size of that base value right there. So again, our domain is going to be the set of all real numbers because this is continuing to go left forever and up and right forever, even though it's just a slight tilt to the right. But our range must stay greater than 0, and again, cannot be equal to 0 because we will never produce a 0 output because there's nothing we can put into this function that will give us a 0 output. Okay, so that's the difference in what they look like. You can see they're very similar, but then this one's much steeper right here. It turns and goes up. You'll also notice something kind of interesting about these parent functions is that they both have a 0, 1 point and a 0, 1 point. I wonder if that's important. Well, we'll find out, won't we? Okay, so that's what you've got for exponential functions. And then, of course, you're going to use your formative here to check your work on this one. You know, plug those in, try your domains and ranges, and, of course, draw your graph for examples 19 and 20. All right? Okay, we got one more type of Mustang to look at in this lesson. I know this one's a little bit long, but once you see all of these, then we'll be able to reference back to them. Now, this one's a little funky looking, but let's go ahead and take a look at it. So here is number 6, and these are called reciprocal functions. Reciprocal functions, and we'll just kind of zoom in here. And again, remember, just try to stay focused on the one problem that we're working on together here. All right, so reciprocal functions, let's make our note up here, is when our input is in the denominator of a fraction. So when our input is in the denominator of our fraction, we have something what's called a reciprocal function. We have a reciprocal function. Okay, now I'm using some decimals over here because, again, I tried to pick numbers for you that would make things easy to graph so you could get an idea of how to do these problems. You can work in decimals, you can work in fractions, whatever is easiest for you. I wrote them in decimals here. I'll probably show you how to convert them in fractions, but we'll just talk a little bit about what these look like just to get you a feel for what's happening here. So let's start with this -4, all right? Well, actually, no, let's start backwards. We'll go backwards. We'll just make it easy, right? So if I take a +4 and I drop it in for an input into my fraction, what am I going to get? I'm going to get 1/4. Okay, that's good. If I take a +1 and I drop it into the input of my parent function here, my reciprocal function, I'm going to get a 1/1, which is just 1. All right, so let's talk about this 0.25. Let's just do a little work over here. All right, so let me rewrite that for you as a fraction because maybe it'll be easier for you to see. What if I wrote that 1/1/4? Right? Well, remember, when we divide a number, what we're really doing is multiplying by its reciprocal. So another way that we could say this is 1 times 4/1. And of course, if we put that over 1, that's just going to produce for us a positive 4. Does that make sense? You see how I did that? All right, so 1 over 1/4 is 1 times 4 over 1. We multiply by the reciprocal. When we divide fractions, we multiply by the reciprocal. Okay? All right, so let's talk about a 0. What happens if I put a 0 here in the denominator? Whoa, can't do it, can we? We can't divide by 0. We just talked about that the other day, right? So we can't divide by 0. That's an NA for us right there, right? Okay, well, that's good to know. We can't have a 0 input. That sounds like a limitation. So how about let's see if we can have, so we know we can have some positive inputs over here. We just can't have a 0 input right there, but could we have negative inputs? Well, let's see what that looks like. All right, well, what happens over here, again, if I just took that same problem, 1 over negative 1/4? Well, then that's going to be 1 times negative 4 over 1, right? And so, of course, when we multiply that, we're just going to get negative 4. If I take a negative 1 and I drop it into that denominator there, well, I'm going to get 1 over negative 1. It's going to give me negative 1. And then if I take a negative 4 and I drop it into that denominator right there, well, that's going to be pretty easy. That's going to give me negative 1/4. And now just think for a second about the direction that these graphs are going to continue to go, right? If I go negative 6, 1 over negative 6. If I go negative 8, 1 over negative 8. If I go negative 20, it's 1 over negative 20, right? So these are negative fractions, and they're getting smaller and smaller and smaller. The bigger the denominator, the smaller the fraction, right? Likewise, over here, as I start to do my positive numbers, we also see something kind of happening. So let's put these points on the graph and see what we got. We'll do these together, all right? So let's go with negative 4 and 1/4. So negative, so I'm kind of zoom in here. So we'll go negative 1, 2, 3, 4, and then a 4th. We talked about that's kind of like here-ish, like that, right? So that's negative 4 and a 4th. And then let's go negative 1 and 1. Negative 1 and 1, like that. All right. All right. And then let's go negative 0.25 or negative 1/4. So, right. So like a 1/4 this way, right? Like right in here, that's a negative 1/4. And then that takes us down negative 4. So we go 1, 2, 3, 4. So now we're down here like this, right? Now we know something, right? We know we can't have, let me see if I do that one again. That one kind of, it's a little sloppy there. So 1, 2, 3, 4. So like that right in there. Okay, good. Now we know something, right? We know we can't have a 0 input. So there can't be anything along this line right here, right? Okay, that's good to know. Well, now let's just think about something for a second. All right. As I continue to go smaller or further to the left down my domain, negative 4, negative 6, negative 8, 20, boom, boom, like that, right? My fractions are going to continue to get smaller and smaller and smaller. They're going to remain negative, right? Because this is going to be a negative value in here. So it's going to be positive divided by negative. They're going to continue to be smaller, 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 smaller fractions, but they'll never turn into a 0. And so what we're starting to see here is that this one's going to continue along in this pattern way, getting closer and closer, ever closer to that line without hitting 0. Now we know that this isn't going to hit 0 here either, and so we kind of see that there's not a linear relationship here, so it's almost like it just kind of comes along here and it sort of curves and then it heads down this way. And then it's going to get closer and closer and closer to that, right? As these numbers get bigger, those fractions are going to get smaller and smaller. We're going to get closer and closer to that line, but we're never going to touch that line because we can't have a 0 input. Does that make sense? All right, now let's go the other direction. So positive 1/4, right? So that's right here, like positive 1/4. We're going to go up 4. 1, 2, 3, 4, like that. So we're going to be up here for positive 1/4, right? And then we go positive 1, 1, so 1, 1, like that. And then we go positive 4 and then 1/4. 1, 2, 3, 4, and up a 4th, like that. And again, we see the same thing happening here as we increase these values. These fractions are getting smaller, right? And so, but they're never going to hit an output of 0. They're just going to keep getting smaller, 1/4 and a 16th and blah, 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 all the way down. Same thing here. When we're going this way, we're never going to hit that 0 line because we can't have a 0 input, right? Because we can't divide by 0. So what we start to see is now this graph is kind of going like this here, and then turning and coming along here and traveling along that line. And so you can see that there's almost two places here that we are forced to say our graph cannot go. And those two places are this 0 line here. Well, that was a really big highlight line. Let's go with a little bit smaller highlight line. So it can't go on this line. We can't have this 0. And by nature of the way that these fractions develop, it's never going to go here either. But everything else works, huh? And so this is what we call a reciprocal function. You get these two kind of mirroring arcs going on here, like that. All right. So then let's talk about domain and range. Now remember, we're talking about the numbers for domain. What numbers can you put in that problem? And for range, what numbers can you get out of that problem? So let's see how you do with domain and range. Give it a try. Let's see what you got. All right, how'd you do? This is what you should have come up with for domain and range right here, right? We know that you cannot have a 0 in the denominator, right? And there's no other math going on here. So the limitation for domain for us is only 0. That's the only number we cannot put in there to process an output. We can't put a 0 in there because we can't divide by 0. But at the same time, if we wanted to get a 0 out here, there is no number that we could put in here to get a 0. We could get other numbers out here, but the only number we can never produce out here is a 0. Okay? Because there's no way for us to do the math and take 1, divide it by something, and get nothing. It just doesn't work. It's illogical. And so that's why we see that our output can never be equal to 0. That's why these graphs never approach that 0 line on the y-axis. They never approach that. And they never cross the 0 line on the x either. So when I say x, but I'm going like this, I'm talking about it's crossing through the x-axis at 0. This is crossing through the y-axis at 0. That's what I mean. The line y equals 0, line x equals 0. In fact, if you remember these right here, these are equations of a vertical line and a horizontal line. Horizontal lines are always y equals something. Vertical lines are always x equals something. You recall that. Okay? All right, so this is what we have for a reciprocal function. And then we have another example that we're going to do together here as well. So why don't you try working on this one and see what you can come up with by taking these inputs, getting some points, plotting them, and see if you can figure out where our mirroring arcs are and maybe where our no-go places are. See if you can come up with that. And then write your domain and range, and let's see how you do. Okay? All right, let's take a look and see how you did. All right, so you notice now that, well, it's almost like the whole thing just sort of kind of shifted, huh? Almost like those red lines shifted a certain number of, that's kind of interesting. Well, whatever. Anyway, so yeah, so you notice like here's our curve here, right? And again, it can't touch +4, right? Because if we put a +4 in here, we're getting a 0 in our denominator. That's a no-no. So in this term, we cannot have a +4 in our domain, and so that means that this input of +4 right here, x equals 4, right? That's a no-go for us, right? But at the same time, as we're doing this problem, we're noticing that there's no way that we could get a 0 output either. There's no number that we could put in here that's going to produce a 0 output, right? 1 divided by anything is going to be some value, right? The only way we'd be able to get a 0 output is would have a 0 in our numerator. So again, this is not going to be able to touch this 0 line for us here at all. And so you can see how these curves are coming along this line and this line here like that. And so this is our domain and our range for this reciprocal function, okay? So as you're working through these questions, again, I would recommend that, you're trying to plug in your values. First, start with making sure you get your numbers right by checking them here in the formative questions. And then once you know that you have them right, and you should be able to use decimals, fractions, whatever you come up with. I put a bunch of different options in there for you. Then once you have those like that, sure what happened here. Oh, I see. Okay, hang on. So then once you have those, we'll probably erase that. There we go. You'll be able to do some different math and see these different pictures. But again, remember that this whole idea of, we've got our parent function here, right? And then all the other functions where our input is in the denominator are derivatives of that. So they're all going to be very similar. It's not like you're going to have, one of those parabola U-shaped curves or a V absolute value here. They're all going to have these two lines that can't seem to cross anywhere. So see if you can identify those and then how the arcs fit the points that you come up with over here. All right, so see if you can do that with those two questions there. All right, well, best of luck to you. There's a whole bunch of different Mustangs that we've looked at today. And so hopefully you'll be able to get a feel. But these are all very common functions in the Algebra 2 world, and some of them we'll be looking at in much more detail. All right, well, talk to you later.